Hi everyone, and welcome back to my flight mechanics class. So today we're going to be covering the aircraft response in the case of the sum of the forces, and essentially what we're going to do is to derive the inertial acceleration of the aircraft and multiply that by its mass in order to derive the equations of linear motion. So if you remember, the EUMs are expressed in the body axis system, and the body axis system moves and rotates with the aircraft. So that means that the inertial acceleration equation will have to account for that. So as you can see, the inertial acceleration is equal to the local acceleration in the body frame, that is dv over dt, plus the contribution of the rotation of the body frame with respect to the inertial frame to the inertial acceleration, and that is materialized by omega b cross v of b. So omega b is the body rates vector, and that will be p, q, and r, with p being the body rate about the body x-axis, q about the body y-axis, and r about the body z-axis. V of b is the body velocity vector, and it is defined by its components u, v, and w, with u being the velocity along the body x-axis, v along the body y-axis, and w along the body z-axis. So what you essentially need to do is to compute this matrix and then add it to the vector on the left. So the I component of a matrix is qw minus rv, the j component ru minus pw, and the k component pv minus qu. So what you need to do then is to add it to the vector on the left, and you will get the inertial acceleration expressed in the body frame. So the final step will be to multiply each component by the mass of the aircraft, and you will get your sum of the forces along the x-axis, y-axis, and z-axis respectively. The final step will be to replace f of x, f of y, and f of z by the forces that we actually found in the previous lectures. So you will get your x, y, and z components of the weight vector, the aerodynamic forces vector, and the thrust vector. So the thrust vector is already defined in the body axis system. The aerodynamic forces vector was transformed from the stability frame to the body frame. And then finally, the weight vector was transformed from the inertial frame to the body frame. And that would constitute your equations of linear motion. That's it for today. Thank you very much. See you next time.